How was our universe born? And if that question seems too complicated, then how about this one? What exactly was there before it? While humanity's brightest minds search for an answer to perhaps the greatest mystery in history, let's take a look at the incredible conclusions they've already reached. In the 20th century, one great man shed light on this mystery: Edwin Hubble. One day, atop Mount Wilson in Southern California, he pointed his powerful telescope at the night sky. He was looking at hazy clouds of gas, which astronomers had seen before. But Hubble realized this wasn't gas. These were entire galaxies, as enormous as our own, and there were countless multitudes of them out there. But that wasn't his main discovery. The main thing was, he discovered something that would forever change our understanding of the world. All these galaxies were moving. So what, you might ask? Well, they weren't just moving, they were flying away from one another. And this could only mean one thing: our universe is expanding. And if it's expanding, then it means that once upon a time, it was much smaller. So everything had a beginning. All that remained was to mentally reverse time and see how it all began. It took scientists decades to piece all the details together and formulate a full-fledged theory: the Big Bang Theory. Imagine nothing. Absolute nothingness, in which the concepts of when and where didn't exist. And amidst this nothingness, there was only a point: the cosmic singularity. This is what scientists call the state in which our entire future universe, all the stars, galaxies, planets, and you and I, was compressed into an incredibly tiny, superheated, and unimaginably dense ball. The pressure and temperature inside this ball were colossal. And at some point, it could no longer contain itself. The Big Bang occurred. This was not an explosion in the familiar sense, but rather a titanic outpouring of energy and matter that gave birth to everything we know. In that very instant, time was born and space came into being. Fundamental physical forces emerged, and the universe filled with a hot cosmic soup of quarks, tiny building blocks from which our entire world is constructed. Gradually, this soup cooled down. Gravity, like an invisible sculptor, began to pull particles together. Quarks assembled into atoms, atoms into molecules. And from them, after millions of years, the first stars and galaxies were born. And all this happened just 12 to 14 billion years ago. It seems we now know how our universe was born. But the big question remains: what came before that? Alan Guth, an American theoretical physicist and cosmologist, dedicated his entire life to this question. Studying the Big Bang Theory, he noticed some oddities. For example, the distribution of matter in the early universe was astonishingly uniform. Yet, logically, after such a powerful explosion, chaos should have remained. Let's run a thought experiment. Imagine we hung a paint-filled balloon from the ceiling and laid out a huge white canvas on the floor. If we drop the balloon, it will burst, and a chaotic blob will appear on the canvas. A bunch of different spots, scattered haphazardly. But the early universe looked nothing like that. It was smooth and uniform. Now, let's imagine a different scenario. Instead of dropping the balloon, let's draw a tiny red dot on the canvas. And now, let's start evenly expanding it, in all directions at once. If we filmed this in time-lapse mode, we would see a perfectly even circle, growing harmoniously. That is precisely how, according to Guth, it all happened. This discovery formed the basis of his theory of inflation. According to it, immediately after the Big Bang, there existed a mysterious force that, in a fraction of a second, imparted a colossal acceleration to the universe. It instantly and uniformly stretched space, smoothing out all irregularities as if someone had perfectly ironed a crumpled tablecloth. Guth's theory was a huge success and is now part of the standard cosmological model. For most scientists, this picture is quite sufficient, but not for everyone. Martin Boyewald, a German professor of physics, believes the universe was born quite differently. Remember that cosmic singularity, the point where it all began? According to Boyewald's theory, it couldn't have emerged from absolute nowhere. That simply makes no sense. But then where did it come from? To understand this, let's look at time. For us, it's like the pendulum of an old clock, swinging smoothly and continuously from side to side. Time just flows, and that's it. But on the most fundamental quantum level, things might be different. Quantum time isn't so much like a pendulum, but more like a clock's second hand. It doesn't flow, it ticks, made up of tiny, indivisible segments. And the beginning of each such segment of time is the end of the previous one. Do you see what he's getting at? Let's go back to our balloon analogy. The Big Bang Theory states that our universe, a long time ago, began to expand, inflating like a balloon. But what if one day this process reverses? What if the universe starts to contract and eventually returns to that very state of singularity? What would happen then? And then, according to Bojewald, there would be another Big Bang. Nothing comes from nowhere and nothing disappears into nowhere. The beginning of our universe is the end of the previous one. It is neither the first nor the last. Countless universes existed before us and will exist after us, in an infinite cycle of births and deaths. This theory sounds very logical, but unfortunately, we don't yet have enough knowledge to find all the evidence, so it remains just a beautiful hypothesis. But some scientists come up with ideas that seem even more unbelievable. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist, are searching for answers far beyond the confines of our reality. They too believe that our universe isn't the first, and that it's caught in a cycle of infinite rebirths. But they see the mechanism of this process quite differently. According to their theory, our universe is situated on a so-called brane. Imagine a gigantic elastic membrane or a sheet of fabric. And we are just one of many such branes that float in a higher dimensional space, like laundry on a clothesline. These parallel universes are very close to one another. Another world could be just a centimeter away from ours, but we'll never see or feel it, because an invisible fourth dimension separates us. So, how do new universes emerge? Through collision. These branes drift very slowly and draw closer to one another until they eventually collide. This collision gives rise to two Big Bangs and two new parallel universes. Then they diverge once more, and in each of them, life goes on. Right now, you and I are precisely at this stage, the stage of expansion following a collision. But one day, this process will come to an end. The branes will converge once more, and a new collision will result in the birth of new worlds. Remember Alan Guth's theory of inflation? The mysterious energy that caused the universe to expand at an incredibly rapid pace? The brane theory offers an elegant explanation for this. The energy from the collision of two universes is the very force that propelled and accelerated our Big Bang. Of course, when we hear that our world is just a mere piece of fabric on a string, it sounds a bit silly. But this idea is based on string theory and M theory, two titans of modern physics that strive to explain absolutely everything in the universe. To arrive at these conclusions, Turok and Steinhardt had to perform a colossal number of calculations and think in 11 dimensions, transcending the limits of the ordinary human mind. Unfortunately, the scientific community at first merely laughed at this incredible theory. But as the authors themselves say, scientists are human too. They are just as afraid of change and the unknown. For it's always terrifying to question what you've believed your entire life. Many centuries ago, people refused to believe that the Earth was round. Quite recently, they indignantly rejected the very idea of the Big Bang. Great discoveries cannot be made without struggle and fear. And that is precisely why Turok and Steinhardt are not giving up. After all, the data we have suggests that each of these three theories is equally possible. Which one is true? Perhaps we will never know, at least not anytime soon. For now, we can only hypothesize and dream. But perhaps one day we'll find the key that opens our eyes and helps us unlock the greatest mystery. The mystery of our origins.